Good morning, teachers. My name is Kathleen Wallace, and I'm thrilled that you are joining us this morning to talk about this amazing method for teaching word problems, the bar model method. We're just getting a few more people in from the waiting room, and then we'll get started. We'll be having a Q&A at the end, and I'm more than happy to answer your questions then. I'm also happy to receive emails from you if you have a question and you'd like to follow up on something. That would be my pleasure. My email will be on the screen when we have the Q&A. And it's wonderful to see everyone. Okay, bar models. For those of us who've taught with Singapore math, they are absolutely amazing. Such a powerful way to help students solve word problems, which a lot of teachers will agree that is the most difficult aspect of elementary mathematics. So what exactly is a bar model? The definition is a bar model is a pictorial representation of the quantitative information in a word problem. More importantly, though, what I like to tell my teachers is that a bar model is a visualization of the relationships between the quantities. And on the right there, you can see this is a basic bar model. And the beauty of this, from my point of view, is that even without the word problem being there, the text is not there. I can tell you what the problem states. There were 6 pieces of might have been ribbon or tape or whatever, and they are all 6 46/100ths along, and they want to know what the total length is. All the information from the problem has been put visually into the bar model. So why are the word problems so difficult? Why is this? I know that we want to go immediately to figuring that it's because of the reading, because we have reading with the word problem. Yes, that's true, but it's not quite that simple. A few decades ago, Australian educational researcher named Newman did a very large study with students to figure out why word problems were so problematic. And she broke it down to five steps. There are 5 steps that the children must go through, students must perform in order to solve the problem. The first one is reading. Can the student read the problem successfully? The next one is comprehension, and that involves both reading comprehension and comprehension of the problem. The third one she called transformation. Transformation is when the student goes from the problem into the mathematics, when the problem is translated, if you will, from the language of the spoken language to mathematical language. Next, she identified the process, and that's basically just doing the calculation of the to find the answer. And then last but not least, encoding, which is when we take that final answer and turn it back into the problem. We refer it back to the problem For a lot of young students, we call this making the answer sentence. What she found was that the most difficult step in this word problem solving process was transformation, that it was going from the problem into the mathematics, which is where students found the most difficulty. And this is where bar models really shine, because what we like to say is bar models provide a bridge between the problem and the mathematics. And here's an example of a bar model. This is taken from our learning platform, eSingapore Math. And as you can see, the transformation has been done. The numbers in the problem have been drawn into proportional bars into the bar model. And the all-important question mark indicates one of the stumbling blocks in that transformation is, what does the problem want us to tell us? And of course, in this situation, we want to know how many fish Lala has now. In other words, what's the total? And as you can see, that bracket with the question mark, very important element of the bar model, indicates what we're looking for. And on the side, we have a little student helper that gives us a little assistance in finding the number of fish. And when I was preparing this today, I thought, well, I can draw out a bar model. I can show you how they're made. But then I was looking around the platform, and the unfolding of the bar models in eSingapore Math is just perfect. So I thought, I can't do a better job of this. So what I'm going to do is show you, this is an excerpt from eSingapore Math, and it shows how the bar model is made. I would like you to notice several aspects of what we're looking for when we're done. But first, I want you to notice, as this problem goes along, this is a fairly difficult problem. I would hope that you're going to be able to see how the bar model makes this fairly difficult problem accessible. Here we go.
A toy robot and a toy soldier cost $19. A toy robot and a toy train cost $23. The toy train costs 2 times as much as the toy soldier. How much does the toy robot cost? Let's draw a bar to represent the cost of a toy robot and another bar to represent the cost of a toy soldier. A toy robot and a toy soldier cost $19 altogether. How do we draw the bars to represent the cost of a toy robot and a toy train? We draw the same rectangle for the toy robot. The toy train costs 2 times as much as the toy soldier. The toy robot and the toy train cost $23 in all. How do we find the cost of the toy robot? To find the cost of the toy robot, we subtract this from this. We get $4. This means that a toy soldier costs $4. To find the cost of the toy robot, we subtract this from this. We get $15.
So I hope you noticed some of the wonderful details about this. So this not only is a two-part problem, but it's also got a multiplicative and additive value. However, and having those two aspects in one problem, I think you teachers would agree could be daunting for just about any student. But when the problem is drawn out, excuse me, it's easy to see the relationships between the quantities.
A toy
So how do we unfold these the use of bar models through the curriculum? In East Singapore math, right away, bar models are introduced, albeit informally, with games in grade 1. And this is a fun little game. As you can see, we've got the robot, and he actually has bars on the lever arms, and we're going to balance it. And we'll see how the children have targeted practice with a bar model concept. Whoops. There we go. And what I appreciate about this game is how it's a game, and we balance the scale, but it's a representation. It's another interface with the concept of the bar, and we're going to see this all through the curriculum. Bar model instruction starts. I've got a question in here. How is it known that the green bar, the robot, was larger than the soldier? Well, we can talk about that at the end. Bar model instruction starts formally in 2nd grade, and here is the this is a very simple part whole addition problem. We'll take a look at that. I think
Lala has 8 Mexican stamps and 11 American stamps. How many stamps does she have altogether? We can draw 8 Mexican stamps and 11 American stamps to represent this problem. It is not easy to draw so many stamps, so we draw a box to represent each stamp. We use 8 boxes for the Mexican stamps and 11 boxes for the American stamps. Are there ways to further simplify the diagram? We can just use 2 rectangles, one for the Mexican stamps and one for the American stamps. We want to find the total number of stamps. We have drawn a part-whole model. This part and this part make up the whole. How do we find the total number of stamps Lala has? We add these together. We get 19. So Lala has 19 stamps altogether.
So as you can see, again, the quantities from the problem are taken out of the problem and placed into the bar model. And because we draw the bars proportionally, it gives the student a concept of not only which value is which, but also the relationship between those quantities. And here's
Lala.
Oops. Here's another one. Now we have the same, this is a part whole problem, but with subtraction.
There were 18 stickers in a box. Alfredo took away 7 stickers. How many stickers were left in the box? We can draw a box to represent each sticker. So we draw 18 boxes. Alfredo took away 7 stickers. How can we further simplify the diagram? We can just use 2 rectangles. One to represent the 7 stickers that Alfredo took, the other to represent the number of stickers left. We do not know the number of stickers left. But we know that there were 18 stickers at first. How do we find the number of stickers left? We subtract this from this. We get 11. Therefore, 11 stickers were left in the box.
Once again, this might be problematic for a lot of students to know that we do need, in fact, to subtract. But the way the model is drawn, we see that there were the entirety of all the stickers and then some went away. So again, the child can see what needs to happen. And you can also, from the process in the video, see how this is a developmental process. Notice how they started with drawing all of the stickers, and then the picture became a little more abstract when the lines between all of the stickers were taken away. So as the children are more experienced with the bars, they can become more abstract. The second graders, once we've been working with our bar models for a while, we get a game as well. And this one it's another bar model scale game. But as you can see, now that we're in second grade, we have moved up a level in abstraction, and the pictures have been replaced by number symbols. So we'll just take would be a reinforcement of the lesson that we just had. Whoops. So this is, again, it's a combination. First of all, we're getting some fact practice, but we're also having the opportunity to visualize the relationship between these numbers. We have on one side of the scale is the are the two parts, and on the other side of the scale is the whole. So it's an all-encompassing activity that on first glance is just a whole lot of fun. So here's another one. This is a comparison problem. This one has it's a 2-step. We have to figure out what the other part of 6 is, and then try to balance the scale on the other side. And here's an example of this. This is second grade also. It's a little mental math exercise. This is a game that illustrates 2-step problems with bar models. If you look in the first example, students have to add to find out how much is in the question mark. So that's reinforcing. The question mark points the children in the direction of what they need to solve. Once we figure out that that bar is worth 44, then we need to figure out what those 2 bars would equal. And we look over here, what would balance the 2 bars. And that, of course, is 54. Now we're moving up to third grade. And of course, third grade is our time when we begin formal study of multiplication. And what better way than to start off with a game? And in this one, notice how we're going back to the first grade example of using objects. This is more concrete than the numbers are. It's more basic. So the students, first of all, can see that when it balances, they need the same amount of groups. And they also see over and over as they practice that multiplication means equal groups. And then we have an example from third grade. Notice how the bar model is pulled out of the concrete and the pictorial with the bags of oranges.
Betty packed 4 oranges into each packet. She had 3 packets in all. How many oranges were there altogether? There are 4 oranges in a packet, and there are 3 such packets.
This is the
Let's draw a
pictorial.
bar model to represent the problem.
Notice how
We draw a
bridge.
rectangle to represent the number of oranges in a packet. How many such rectangles represent the number of packets Betty had? Betty had 3 packets, so we draw 3 rectangles. There are 4 oranges in a packet. We need to find the total number of oranges. We have drawn a part-whole model. Each of these rectangles is a part. Each part represents a group of oranges. All 3 parts make up the whole. How do we find the total number of oranges? There are 3 groups of 4 oranges. So we multiply 3 by 4. We get 12. Therefore, there were 12 oranges altogether.
So this is an example yet again of how, first of all, the bar models in general can make that bridge from the problem to the bar model, but to the numbers. But notice how we use that more concrete example of showing the actual oranges in the picture. So the bar model, the whole concept of the bar models is developed over a long time. Here's an example, just a picture of division in grade 3, and they're taught pretty much alongside one another. Again, developmentally, we have the potted plants, and we go ahead and just draw all of the 18 potted plants. As students become more savvy, though, they think, do I really want to draw each of those 18 potted plants? I don't have to. I can draw a bar to represent the potted plants, and I can label it the 2 rows as being 18. But once you look down at that at the bar model, you can see easily that you need to divide 18 into 2 equal parts to find out how many are in each row. That's grade 3. And we get another example. The third graders can practice their multiplication and division with the bar model robot. This is an example of, we need to find these 4 parts. So on the left side, you can see how this would be 2 bars, and we would show the total of 44. And then we need to know what does each bar equal. And the calculation is accessible, but still an interesting challenge, dividing 44 by 4. Fourth grade, not to be left out, we have more challenging problems with more challenging numbers. Here's an example of a 4th grade bar model.
Mr. Williams is 193 centimeters tall. Elton is 137 centimeters tall. What is the difference in their heights? This phrase shows that a comparison is being made. Let's use a comparison model to represent this problem. Mr. Williams is 193 centimeters tall. And Elton is 137 centimeters tall. We do not know the value of this. How do we find the difference in their heights? To find the difference, we subtract this from this. We get 56. Therefore, the difference in their heights is 56 centimeters.
So you can see in this
Mr.
fourth
Williams.
grade example how
Mr. Williams is
it's more sophisticated, and we go more directly from the problem to the bars, and we start skipping that concrete and pictorial piece. Here's the game for fourth grade. This another two-step problem, but it's a familiar game, so they know how to do it. So obviously we need to add the two values on the low side and then find that 3 equal parts on the right side. So again, we're combining the some mental math and some structural problems with the concept of the bar model. Fifth grade, in particular, the bar models really shine in fraction work. So let's take a quick peek at Brenna and her pizza.
Betty bought a pizza.
Oh, Betty. Oh,
She gave one
Betty and
half of
Brenna.
the pizza to Brenna and 5/12 of the pizza to Kelly. Who received more pizza, Kelly or Brenna? What fraction of the pizza did Betty have left? Let's draw a bar to represent the pizza. How many equal parts should we divide this bar into? We first need to rewrite the fractions so that they are like fractions. 1/2 can also be written as 6/12. So we divide the bar into 12 equal parts. 1/2 of the pizza was given to Brenna. This is equal to 6 out of 12 parts. Five-twelfths of the pizza was given to Kelly. We have drawn the model for the problem. Who received more pizza, Kelly or Brenna? We can see that Brenna received 6 out of 12 parts, and Kelly received 5 out of 12 parts. 6 parts is greater than 5 parts. Therefore, Brenna received more. Betty bought a pizza.
Of course, it's a two-step problem, so we're going to know at the end that Betty had, I think, 1/12 of the pizza left. But you can see how fractions, which are so problematic for kids, so challenging, can be made accessible through the use of bar models. And of course, not to be left out, the fifth graders have an opportunity to practice with the robot. Look at the sophistication of this fifth grade level game. Challenge. And these games are loads of fun to play. I know that was a lot of information all at once. I am happy to answer questions in the chat. Let's see if I can unmute everyone. Please go ahead, feel free to type any questions you have in the chat. If you're not able to stay with us for the chat, the Q&A, I want to thank you for joining us today. I did say I would I'll put this screen up while we're chatting. We are happy to provide you with a free 30-day trial of eSingapore Math so that you can you can start working on bar models and all aspects of Singapore math. How do we get access to the math games? The math games are part of the eSingapore platform, and so you're welcome to try it out for 30 days, and then the games are part of the entire platform. It's my pleasure. I'm glad you found that insightful. Thank you, Ruha. So there's my email address, and I am happy to answer any. That is another, okay, first of all, thank you, Lindsay. If you would be so kind as to send me, I guess I can copy this, send me an email. It's my pleasure, Sunika. The cost, actually, we are looking into the title funds, Karen. If you would send me an email, I can get back to you with details about that. Oh, Allison, I'm glad it was worth it for you to get up on the East Coast. Yes, I can imagine. Thank you, Lindsay. I'm glad you found it informative. I absolutely know that the not only the bar models and the games, but the entire Singapore math approach works really well with special ed kids. I know because I taught special ed classrooms for many years, and the reason the special ed kids respond to this is because so many of them are visual, and Singapore math focuses on, by focusing on the concrete tools and the pictorial approach, we have lots of success with children with in special education. I know we said it would be 30 minutes. I'm happy to stay for a few more minutes if anyone has any further questions. And again, there's my email. I'd love to hear from you. It's my pleasure. Thank you for joining us. Yi Rui Liu. Hopefully I said that right. My pleasure. It's my pleasure, Baha. Thank you for joining us. Yes, Danyai, send me a please send me an email and I'll be able to do that. Yes. Well, I'm really happy to hear that. I think that's terrific. I'm not surprised that you love it because I know as a math educator, it's an excellent platform.
Oh, I'm sorry. I didn't see that you unmuted me.
I did. I finally, I'm embarrassed to say it took me all that time to figure out how to do it. But am I right, Danielle?
Yes, that's correct. You could say Danielle or Danielle.
Danielle, got it. Well, I'm glad to hear you're enjoying the program. I think it's excellent.
Yes, my little one attends a homeschool hybrid,
Uh-huh.
and they use it as part of their curriculum. And this year we changed the schedule where I will do more of the homeschooling. And so I immediately purchased that because he loved the online and I loved the teaching videos that precedes the lesson. And
Well,
he loves the games.
I'm glad to hear that. The instructional videos are excellent. They're short and sweet,
Yes.
but they get the job done. And then, of course, it's followed by what we like to call targeted practice. It's not just the random practice that you see in a lot of programs, but it reinforces the concept. Because in Singapore math, we say that we teach to mastery. So I'd love to let me know how it's going, and I'm happy to answer any questions that you might have.
I will. Thank you so much.
My pleasure. Have a great school year.
Thank you.
Yes, I figured out how to unmute, so if anyone has a question, I'm happy to do that. Happy to answer. And it looks like maybe we're done. So I'm going to thank you all again for joining us. I encourage you to try out the trial and see what you think. And as I said, there's my email address. You can access the free trial by emailing me, and also keep my email, as I'm more than happy to answer any questions